Alright, so here's an example of a correlation regression problem like what you might see on the graded homework. So here we have 9 houses and their sizes in hundreds of square feet along with their monthly rents. So here this first line means this was a house that had 1,200 square feet and was $875 a month in rent, for example. So all of these are in hundreds of square feet. So they want us to construct a scatter plot using the size of the house as the independent variable. It makes sense that that would be our independent, since you wouldn't necessarily want to predict the other way. You'd want the size to predict the rent, not the other way around. We want the sample correlation. We want to test if there's a linear relationship between the two variables, the regression equation, and then we want to use the regression equation to predict the rent of a house that is 1,100 square feet. We'll go ahead and say here that for number 5 we need to be careful of the units, because 1,100 square feet means X is 11. Okay. So let's pull up StatCrunch. So we'll go over to my stat lab, we'll pull up StatCrunch. And I will copy the data. Type or paste into a blank table. So we'll just Control V. We want our delimiter to be white space. That's the way I'll always have it. And just for the sake of clarity, because it'll help us later, we'll change our variable names to size and rent. So everything we need to do, just like we said before, is under regression, simple linear. Our X variable is the size of the house. The Y variable is the rent. We're doing a hypothesis test for the slope equals 0 versus not equals 0. Remember, the slope is the same as testing the slope is the same as testing the correlation. You can here, if you want to, do a prediction where X equals 11. You don't have to do that. You could just do it the other way we talked about. Do a fitted line plot under graph, and then that's all we need. Compute. Make this bigger so we can copy all of it. We need to make it even bigger than that. Well, I guess we can't copy that all at one time. Alright, so we'll just copy and paste this over here. Control C to copy. And go over here and Control V to paste. And then there's actually more down here. I think. Well, there. Okay, I guess it didn't register our prediction. So, but there's our graph. So we want to copy the graph. Right click to copy. I want to copy image. And then the reminder down here to choose Alt Control V once we get into Word. Okay, so our first question is to do the scatter plot. So number 1, so we've already copied our scatter plot, so we'll do Alt Control V to paste. Device independent bitmap. There's our scatter plot. I'll shrink it down. So from looking at this, you can see that there is an increasing trend. It's a pretty strong trend too. You can see it's they're pretty well. The dots are pretty well centered around the line. They're pretty tightly centered around the line. That's what I should say. Calculate and interpret the sample correlation for this data, number 2. What you can do is just go back up to your output, copy it, and paste it down here. And don't forget to interpret it. So this is a positive correlation because it's a positive number and not a negative. And this is very close to 1, so we'll say it's a strong positive linear relationship. Alright, so that's number 2. Number 3. Test to determine if there's a linear relationship. Now, we know that in the data there's a strong positive linear relationship. We said that already. But the question with the hypothesis test is, can we determine that there is a linear relationship in the population? So, H naught will be rho, and you can go and get that from symbols. Equals 0 versus the alternative hypothesis, rho not equal 0. And you can also get the not equal to from there too. Alright, now we need the test statistic. And the test statistic is up here under slope. So the t-stat is under the test statistic. We can just copy that. And then notice the p-value is less than 0.0001. So the t-test statistic is there, and then we said the p-value is less than 0.0001. So we need to reject H naught if the p-value is less than 0.05, and we know that the p-value is less than 0.0001, so for sure we're going to reject H naught and say that there is sufficient evidence to conclude a linear relationship between size and monthly rent. Okay, so that's number 3. State the regression equation. So again, we can just come back up here, Control C to copy, come down here, Control V to paste, and that's our regression equation. And finally, use the regression equation to predict the rent. So I'm just going to recopy the regression equation, but replace size with 11. And we can pull up the calculator. Be careful of your order of operations here. This is the part that StatCrunch would have done for us, but it didn't seem to recognize it. Somehow it didn't register. But that's okay, we can just do this. So 31.6667 times 11. And then we're going to add that to 449.4444. And we predict 797.78. And this is dollar amount. So we predict that it's a house that is 1,100 square feet would have a monthly rent of $797.78. All right. So let me know if you have any questions, and I'll be glad to answer any you have. All right.